Math 1332, Chapter 10, Probability and Counting Techniques. Section 4, Tree Diagrams, Tables, and Sample Spaces. Video 3, Calculating Probabilities Using Tables, Deck of Cards. Before we move on, I should point out that all of these have used sample spaces. The tree diagram illustrated the sample space. A table is about to illustrate a sample space, in this case with a deck of cards. Now, I know not everybody may be familiar with how a deck of cards is composed, so allow me to explain and give you an illustration. A standard deck of playing cards has 52 cards. 52 comes from 13 times 4. That is a very handy fact to know in these probabilities, that 52 is equal to 13 times 4. Not sure what happened there. There we go. All right, but I continue. There are 3 ways to partition cards. Number 1 is by color. There are 26 red cards and 26 black cards. 26 is half of 52. It's also 13 times 2. Suit. There are 4 suits: clubs, diamonds, hearts, and spades. There are 13 clubs, 13 diamonds, 13 hearts, 13 spades. And by the way, clubs and spades are black, diamonds and hearts are red. I want to clarify that because there are some decks of cards where diamonds are blue and clubs are green, just so that each suit has a different color. We will never assume that. We will always assume clubs and spades are black and diamonds and hearts are red. Rank. There are 4 each of the following ranks: ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. Now, the order of the cards is irrelevant. Typically, 2 through 10 are in that order. Looks like there was a number missing. And then after 10, it usually goes jack, queen, and king. Depending upon the game you're playing, sometimes ace is low and treated like a 1. Sometimes ace is high and treated like higher than a king. Sometimes it plays both roles. But we're not going to be concerned with which card is higher than which. We just need to know that there are 13 ranks, ace through king. And there are 4 of each. Like, for example, there's 4 aces: ace of spades, ace of clubs, ace of diamonds, ace of hearts. By the way, every card has 1 suit and hence 1 color, and also 1 rank. I think everybody knows that. Also, the jacks, queens, and kings are called face cards. So if you ever talk about face cards, it means cards with a face: jack, queen, and king. You will be provided a diagram of all 52 cards, and I'm going to go ahead and show you what that diagram looks like. It looks like this. This will be available as a PDF in Canvas in the module containing these videos, and I highly recommend you have a copy of this in your notes, and you know why. But it does have each, if you notice, each row represents a suit. The top row, I can draw on this. The top row are clubs. The second row are hearts. The third row are spades. And the 4th row are diamonds. And you may not be familiar with all the shapes. The hearts are pretty obvious, so are the diamonds. But the one that looks like a puppy dog paw is a club. And the one that looks like a shovel is a spade. I think that's actually why it's called a spade, because it kind of looks like a shovel. So, but the rows are organized by suits. The columns, by contrast, are organized by rank. This column is the aces, this column is the 7s, this column is the queens. Now, I will admit that in this diagram, the face cards do not have faces on them, but the face cards are the jacks, queens, and kings, so there's 12 of them. All right, so let's take a look at some probability questions. If I can find the whiteboard, there it is. All right. Remember, all of these have 52 cards, so it's going to be out of 52 because we don't do conditional probability in this class. Find the probability of each event if you draw a single card from a standard deck. A 9. Well, let's go ahead and put over 52 for all of these because all of these are going to be out of 52. I'll pause and fill them all in. And you may notice that I am using horizontal fractions because there's 8 rows of questions, so there's not much room vertically. So we use the diagonal slash to represent fractions. Okay, Some of these you may not even need the diagram to look at. Probability you draw a 9. Well, how many cards are 9s? There's 4 of them. 9 of clubs, 9 of diamonds, 9 of hearts, 9 of spades. But you can just look at the picture. Here's the 9s. And there are 4 of them. So the first probability is 4 out of, come on, go. 4 out of 52. Now that will reduce, and you remember what I told you to know about the number 52. It is 13 times 4. So we can divide both sides of this fraction by 4. That would give 1 on the top, 13 on the bottom, and there's our first probability. 1 in 13 chance you draw a 9. What is the probability that you draw a heart? Well, if we know how many hearts there are, we put that number on the top of this fraction. How many hearts are there? Well, there's no shame in counting them if you don't know. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are 13 hearts. Come on, there we go. All right, so since there are 13 hearts, that means that the probability of drawing a heart is 13 out of 52. And remember what I told you to know about the number 52? It's 13 times 4. We can divide both sides of this fraction by 13. That would give 1 on top, 4 on bottom. There's a 1 in 4 chance of drawing a heart. And if you think about it, that makes sense because there's only 4 ranks and they're all equally distributed. So you got a 1 out of 4 chance of drawing a heart. What about the ace of spades? How many cards are the ace of spades? Well, there's only one ace of spades. But if you want to look at the picture, I don't blame you. The ace of spades is right here. And it is the only ace of spades in the deck unless somebody's trying to cheat. So there's only one card. That is the ace of spades, which means the probability of getting the ace of spades is 1 out of 52. That won't reduce. By the way, I'm not turning these into percents because dividing by 52 usually doesn't come out clean. In fact, B is the only one that comes out clean. 1/4 is 25%. D, a 2 or a 6. All right, this is where you have to be a little bit more aware, especially of the word or. Oh, wait a minute, starting to have flashbacks from symbolic logic and disjunctions and all that jazz. Just a reminder, a disjunction and or is true when, the rule for or, the rule for disjunction was a disjunction is false only when all of it's false. So when is it true? When either half of it is true. So say 2 or a 6 means it can be a 2 or it can be a 6. I think I just said a whole lot of words for no reason. Probably wouldn't be the first time. How many 2s or 6s are in the deck? Find all the cards that are 2s or 6. Well, there's 4 2s and there's 4 6s. It's a total of 8 cards. 8 cards in the deck are either 2 or 6. And notice in this case, it can't be both because each card has a single rank. 8 out of 52. I can reduce that by 4. 8 divided by 4 is 2. 52 divided by 4 is 13. A 7 or a club. Here's where we have to be a little bit careful. It does say the word or, which means it's just got to be one or the other. Could it be both? Could a card be a 7 and a club at the same time? Of course, the 7 of clubs. The 7s are here. There's 4 of them. The clubs are here. There are 13 of them. How many total cards did I circle? I circled 4 the first time, 13 the second time. 4 plus 13 is 17, but I did not circle 17 cards. Why? Because if you say 4 plus 13, you are counting this 7 twice. There's only 16 cards circled. And if you're starting to have flashbacks of cardinality of the union of 2 sets, it's not a coincidence because in set theory, or means union. But regardless, there are 16 cards here. The 4 7s, the 13 clubs, but the 7 of clubs got counted twice, so we have to subtract it once for a total of 16 cards. Which means the probability of getting a 7 or a club is 16 out of 52. We can reduce both sides by 4 to get 4 out of 13. A diamond or a spade. Let's try this one without the table. How many diamonds are there? 13. How many spades are there? 13. Can any card simultaneously be a diamond and a spade? No, every card has one rank. So there are 13 plus 13, which is 26 cards that are diamonds or spade. That reduces to 1/2, which makes sense because diamond and spade is precisely 1/2 of the ranks. A black queen. How many black queens are in the deck? Do you need the table? If you do, that's okay. If you don't, that's okay. But how many black queens are in this deck? Let's find them. There's the queen of clubs, queen of spades. There's only 2. There are 2 black queens in the deck, which means the probability of getting a black queen is 2 out of 52. We can reduce this by 2 and it becomes 1 out of 26. And then lastly, a red card or a king. All right, maybe we should use the diagram. Here's the red cards. There's 13 here and 13 here. Let's go ahead and write 13 plus 13. That's 26. Oh yeah, half the deck is red. 13 or a king, so it can be these also. Now what's the problem with adding 4? Who got counted twice? 2 guys. The king of diamonds and the king of hearts got counted twice. So if you're going to do 13 plus 4, get ready to do -2 because 2 cards got counted twice. That would be 28 total. If you're worried about duplicity like that, then just count them. Just circle them and then count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 26, 27, 28, which is what I got down there. There's no shame in that. Just make sure you don't double count somebody if they fall under more than one categorization. 28 out of the 52 cards are red or kings. We can reduce that by 4 to get 7 out of 13. So probability with cards is actually pretty straightforward. The hardest part is when something might get counted twice, like when you say a 7 or a club in example E, because there are 4 sevens and there are 13 clubs. 4 plus 7 is, 4 sevens, try it again. There are 4 sevens and 13 clubs. 4 plus 13 is 17, but it wasn't 17 because when you did that, you count the 7 of clubs twice. It was really just 16. Feel free to use the table to help keep your thoughts organized. I would.